today today we are going to do numericals on the same chapter, motion in a straight line. So first one is this one: an electron traveling with a speed of 5 into 10 to the power 3 meter per second passes through an electric field with an acceleration of 10 to the power 12 meter per second square. Then you have to find out, one, how long will it take for the electron to double its speed, and next one is what will be the distance covered by the electron in this time. So this thing we have to find out. First you have to write down what are the information given here. So first is given, u is given, so that is the initial velocity, electrons traveling with a speed of 5 into 10 to the power 3 meter per second. So that means solution here. So u is equal to 5 into 10 to the power 3 meter per second, and acceleration also given. A is equal to acceleration 10 to the power 12. So 10 to the power 12 meter per second square. Now it is said that the velocity will be doubled. Okay, how long it will take for the electron to double its speed? So it will be doubled. That means v will be 2 into 5 into 10 to the power 3 meter per second. So if we calculate this one, we'll get some value that we'll calculate later. So first we have to find out the time. So first how long means you have to find out the time here. So you can write t is equal to what? T is equal to v minus u by a, because v is equal to u plus at. So in that formula, if we put, so you'll get t is equal to v minus u by a. You can write down the formula, v is equal to u plus at. So at is equal to v minus u, and t will be equal to v minus u by a. You can write down here. Now v is 2 into 5 into 10 to the power 3 minus 5 into 10 to the power 3. What is a? 10 to the power 12. Okay, so if you calculate, you will get 5 into 10 to the power 3 by 10 to the power 12. So I'll tell you one thing, if this 10 to the power 12 will go here, then it will become 5 into 10 to the power 3 into 10 to the power of minus 12. So which is nothing but 5 into 10 to the power of, then you have to subtract 3 minus 12, because power is always get subtracted. Why? Because a square into a square, right? A to the power 2 plus 2 is equal to a to the power 4. So in case a square into a to the power minus 2, then we will also add, so a to the power 0. A to the power 0 means 1. So we'll get 10 to the power minus 9 second. Okay, so calculation is little bit difficult, but if you can understand this one, easily you can find out. So next one is 2. What is called what will be the distance covered by the electron in this time. So distance means that formula you have to use, s is equal to ut plus half a t square. Okay, so time already we have calculated here, 5 into 10 to the power minus 19. Then we'll put the value here. U is given here, u is 5 into 10 to the power 3 into t is 5 into 10 to the power minus 9 plus half. A is given here 10 to the power 12, and t square means you have to square this one. So squaring means 5 into 5 will become 25, and 10 to the power minus 9 into 10 to the power minus 9 will become 10 to the power minus 18. So 10 to the power minus of 18. Okay. So now we calculate here. First we calculate for the power. So this is 25 into 10 to the power 3, and this one is how much? 9. So we'll get minus 6. Plus then 2, and this will calculate, this will be divided, you'll get 12.5 into 10 to the power, again you'll get 10 to the power minus 6. Okay, so take common, 10 to the power minus 6 will be common, so 25 plus 12.5. okay, so if you add this one, you will get 3.75 into 10 to the power actually 25 plus how much? 25 and 12.5, so 5, then 7 and 3, 37.5. so 37.5 you can write also 37.5 into 10 to the power minus 6, or you can write here, 3.75 into 10 to the power minus 5. okay, so you can write this one 37.5 to the power minus 6, or you can write 3.75 into 10 to the power minus 5, so it will be nothing but meter. Okay, so this is the answer. These two answers we found out. This one, hope you can see this. Okay, now we go to the next problem. Next problem in the next page. Just to rotate this. So I read the sum first. So a motor car starts from a rest. A motor car starts from a rest. Let's adjust this. Okay. So a motor car starts from a rest and accelerates uniformly for 10 seconds to a velocity of 20 meters per second. It then runs at a constant speed, and it finally brought to rest in 40 meters with a constant acceleration. Okay. Total distance covered is 460 meters. Find the value of acceleration, retardations, and total time taken. So this type of sum also you can do normally with the formula, but here we will do using graphical method. Normally we'll do graph. So first we'll draw the graph. So here we'll draw the velocity time graph. So this is the velocity and this is the time. This is your origin. Okay. Now see what is given here. It has started. The motor car starts from the rest and accelerates uniformly for 10 seconds with a velocity of 20 meters per second. That means it started from here like this. It is accelerating. Acceleration means the velocity will increase. Now this much of velocity is 20 meters per second. Now what will happen after that? At a constant speed, okay, and it runs at a constant speed and finally brought to rest for in 40 meter with a constant acceleration, retardation actually here. So it will remain for constant for some time, and then again it will finally brought to rest with some retardation. Retardation will come to 0 because it is finally come to rest. So this is the graph. Now in this case you can find out three things happen. This is acceleration, this is constant velocity, and this is retardation. Okay, so here the time is given. This is 0, this one is one time, this is another one. So you can give the name O, A, B, C, D, E. So this time This one is actually 10 second time. Now B to D, we don't know the time actually. We don't know how much. So you can write T2 question mark, and D to E, how much time it takes. We don't know that one also. You can take as T3. So that you have to find out. Only things are given. The total distance is given. Total distance is 640 meter. The meaning of this one is the total area of this total portion is 640 meter, because it is a velocity time graph. So if I find out the area, you will get 640 meter. And also one more thing is given, that the area that it will brought to rest at in 40 meter. So that means the area of this graph, this portion, means CBE is also is 40 meter. Okay, so first thing you have to find out the acceleration here. This is acceleration. So acceleration, I don't, for the first part of motion, acceleration. So you'll find out. So they're going to find out acceleration using the slope. So slope of this graph. So acceleration, you can write A is equal to slope of this. How to find out the slope? AB by OB. So AB by OB. What is AB? AB is 20. What is OB? Is 10. So you'll get 2 meter per second square. That is acceleration. Okay. Now you have to find out the distance. This distance. So distance traveled for the first half. So distance travel. So distance we are calculating for the first half only. Okay. First half means this one is only the first half. So distance traveled. We can write it S1. S1 is equal to area of this portion. So half into base is 10, into height is 20 meter. So you'll get 10. So you'll get 100 meter. So this portion will become 100 meter. Okay. Now already you know the last one, the area of this CDE already given. This is 40 meter. Okay. So you can write this is S1 and this one is S2. This is S3. So you have to find out S2. So already given S1 plus S2 plus S3. Now in the next case, so you can write for the second part of motion. Second part of motion. What you can write? S1 is 100. S1 is 100 meter. S2 is equal to, we don't know, and S3 is given here 40 meter. So, and also given total distance covered is given. So S1 plus S2 plus S3 is equal to 640 meter. So we put the value here, then it will calculate the S2 very easily. So how much will get? S2 will be 640 minus, right here, 100 plus S2 plus 40, 640, or you can find out S2 is equal to how much? 640 minus 40, 600, 500. Okay, then 500 meter. So that is one answer we got here, 500 meter. Now what is T2? How to find out the T2? The object was moving in a uniform velocity here. The velocity was constant. So with that uniform velocity, the object traveled how much? Object traveled 500 meter distance. So time taken. So time taken to travel S2 distance. So time taken to travel S2 how much? That is equal T2 is equal to distance by velocity is the time. So S2 by velocity is how much? 20 meter per second. So S2 is what? 500 divided by 20. So we'll get how much? We'll get 25 25 second. So now in case of the third part of the motion, so what do we have to find out? We have to find out what are the things are given. First we'll check it out. So find the value of acceleration, already we found. Then you have to find out the retardation. You have to find out this retardation, and also you have to find out the total time taken. So already we found this one, T1 already we found is 10 seconds, T2 is 25 seconds. So now you have to find out the retardation. But what we do not know that T3. Okay, so you have to do something. What you can do here? We have to find out the retardation, but we know that S3 is 40 meter. So if you find out the area of this one, we'll get the acceleration. So for the third part, for the third part of motion, there's a part of motion. So we get area half into base is unknown, T3 into half into base into height is how much? 20. Then we'll get how much? 40 meters, sorry, 40. So from here we can get T3 is equal to, so this will become 10, so T3 is equal to 4 seconds. So T1 is 10 seconds, T2 is equal to, already we calculated, I think T2 is equal to 25 seconds, and T3 is equal to 4 seconds. Okay, now total time if we can add, we can find out. But how to find out the retardation? That you have to find out. So see, to find out the retardation, the velocity was how much? 20, and now the velocity came to 0. Okay, or you can find out the slope of this graph. That also you can find out. But if you want to find out retardation, A is equal to, we know that is the formula is final minus initial by 2. That also you can do. What is the final velocity? 0. What is initial? 20. So 0 minus 20. How much time it takes? 4 seconds. So 4. You'll get minus 5 meter per second square. That is the retardation. Okay. Or also you can find out in different, you can find out the slope also, perpendicular by base. You'll get slope. Then 20 and by 4. Okay, that will also get minus 4. So that is the retardation we found. Acceleration already we found where? This is this one, the acceleration, retardation, the total time T is equal to T1 plus T2 plus T3, which is nothing but T1 is how much? 10 plus T2 25 plus 4. So it will be equal to 25 plus 10 is 35 plus 4 is 39 seconds. So 39 seconds. So these are the answers. Okay. So in this sum consists of different types of problems. So that is what we are doing. So thank you very much for today.